Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into the overlooked corners of the universe. We've all heard of black holes, those cosmic celebrities that steal headlines and imagination alike. But beyond their dramatic pull lies a quieter story, a universe full of subtle marvels, the kind that whisper rather than roar. Before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe. Only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Now, feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey into the quiet wonders of the cosmos together. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here, quietly unfolding the story. When you picture the universe, chances are that black holes slip into your mind almost immediately. They are the cosmic showstoppers, the symbols of destruction and mystery, capable of swallowing light itself. They feature in science fiction plots, late-night documentaries, and even casual conversations about space. But the cosmos is not just a theatre of explosions and collapse. Much of it is composed of gentler, subtler players, phenomena that rarely claim the stage but quietly shape the script. These are the universe's unsung heroes, and tonight we're going to let them step into the faint glow of attention they deserve. Imagine you're walking through a city at night. The neon lights flash, cars rush by, and music seeps from crowded cafes. It's loud, dazzling, and almost overwhelming. Yet, if you take a side street and keep walking, eventually you stumble into a quiet park, where the hum fades, and you notice things you never would have caught before. The rustle of leaves, the scent of damp grass, the distant call of an owl. The park was always there, but you needed to step away from the noise to hear it. In the same way, our universe is full of quiet parks, places where remarkable things are happening, but softly, almost shyly, overshadowed by the neon glare of black holes. These quieter cosmic marvels are not less important. In fact, they may be even more fundamental to the structure of reality. Black holes dominate because they dramatize physics, extreme gravity, warped space-time, singularities where equations seem to crumble. They are irresistible to storytellers. But what about the invisible hands that hold galaxies together? The faint embers of stars that once blazed like suns, or the silent rooms between clusters where hardly a single atom drifts? These are not cosmic catastrophes. They are cosmic continuities. They remind us that the universe is not only built on drama, but also on patience, stillness, and balance. One of the most overlooked truths is that black holes are relatively rare. In the Milky Way, we suspect there are a few million of them. That sounds like a lot, until you remember that there are hundreds of billions of stars. For every black hole, there are countless stars ending their lives quietly as white dwarfs, or cooling slowly into objects so dim they're nearly invisible. For every violent collapse, there are dozens of subtle shifts, atoms drifting, galaxies settling, planets wandering without suns. If black holes are the fireworks, then these are the candle flames, glowing long after the noise has faded. It can be comforting, even grounding, to think of the universe this way. Life on Earth is often noisy and chaotic, full of events that demand attention, yet so much of existence is held together by quiet forces, the steady beat of your heart, the gentle pull of gravity, the unseen work of air nourishing your lungs. The cosmos mirrors this. Black holes may grab headlines, but the universe truly runs on quieter processes, gravity wells that never collapse into singularity, radiation that lingers like a faint aftertaste of creation, and vast spaces where emptiness itself becomes structure. As we begin our journey tonight, let's shift our focus from the bright fireworks to the faint embers. We'll visit dark matter halos, invisible yet essential, sculpting galaxies like unseen architects. We'll look at neutron stars and pulsars, the so-called zombies of the cosmos who glow and spin long after death. We'll trace the ancient afterglow of the Big Bang, not in its blazing birth, but in the faint whispers left on the fabric of space. We'll drift into cosmic voids, those enormous quiet gaps in the universe that stretch farther than imagination, yet hold deep clues about how everything expands. And we'll stop to notice lonely travellers, planets without suns, galaxies that have stopped making stars and stars cooling into silence. Every one of these phenomena is quieter than a black hole, less dramatic perhaps, but together they compose a kind of cosmic lullaby. A story not of destruction, but of persistence. Not of loud collapse, but of subtle transformation. The universe does not only roar, it also sighs, hums and whispers. And sometimes it is in the whispers that we find the deepest truths. So, as you lie back and let the night wrap around you, imagine we are setting out on a gentle expedition. No rockets thundering to life, no countdowns echoing in your ears. Just a slow drifting outward, past the chatter of the well-known, into the vast library of quieter marvels. Each page we turn will reveal something faint yet profound, waiting patiently to be noticed. And who knows? In the stillness, you may find not only the secrets of the universe, but also of a reflection of your own quiet strength, the part of you that endures without spectacle, steady as the stars. If we just spoke about the unsung heroes of the cosmos, tonight's next step is to linger on the reason why quietness itself matters. Why focus on the subtle, the hidden, the easily ignored, when the universe dazzles with phenomena that seem far more spectacular? To answer that, imagine your own life for a moment. Think of a piece of music you love. Perhaps it's classical, perhaps it's something more modern. If you listen carefully, you'll notice it isn't only the notes that create beauty, it's also the pauses between them. The silences carry weight. Without the quiet measures, the notes would blur together into noise. In much the same way, the universe needs its silences, its subdued phenomena, in order for the grand symphony of creation to make sense. Black holes are like the crashing cymbals in that music, powerful and impossible to ignore. But cymbals alone do not make a song. They need the gentle strings, the background harmonies, the faint resonance of a piano played softly in the distance. The quieter cosmic structures, dark matter halos, white dwarfs, rogue planets, and cosmic voids are those harmonies. They are the scaffolding beneath the drama, the foundation that allows the loud events to happen in the first place. To appreciate the universe fully, we need to learn how to listen not only to the crashes, but also to the whispers. The truth is that the universe, for all its chaos, spends most of its time in states of calm. Stars may live for billions of years, steadily burning, only to flare dramatically in their final days. Galaxies evolve slowly, their transformations measured not in seconds but in eons. Even cosmic expansion, the backdrop of everything, proceeds quietly, a steady stretching that is imperceptible on human timescales. Black holes may make headlines, but the steady glow of countless stars and the invisible embrace of dark matter do most of the work of holding things together. It is almost as if the universe prefers stillness and continuity, with drama only as punctuation marks in a much longer sentence. We humans are naturally drawn to drama. Our hearts race when something unexpected happens. Our attention locks onto extremes. But if you think back on the memories that make your life feel rich, you might notice many of them are small, quiet things. The smell of fresh bread in the morning, the way sunlight bends through a glass of water, the sound of rain against the window while you're wrapped in a blanket. None of these would make the news, but they are the moments that linger, steady and grounding. The cosmos works the same way. Its beauty is not only in the cataclysmic, but also in the ordinary persistence of silence. The quieter oddities of space also remind us of humility. They whisper that we are not at the centre of the story. Dark matter, which we cannot see, outweighs the matter that makes up stars, planets, and people by a factor of 5. Cosmic voids, which appear empty, shape the large-scale pattern of galaxies as strongly as the galaxies themselves. Even the faint microwave glow left over from the Big Bang, almost imperceptible, holds more information about the universe's history than all the bright stars combined. The lesson is that power does not always roar. Sometimes it hums softly, invisibly, but with influence beyond imagination. When scientists study these quiet phenomena, the tools they use reflect the same delicacy. Instead of telescopes pointed at fireworks, they measure slight distortions in starlight, subtle ripples in background radiation, or faint traces of gravitational influence. It's a bit like trying to reconstruct the shape of an invisible sculpture by watching how fog swirls around it. The sculpture itself never appears, but its outline emerges in the patterns. To listen to the universe this way is to slow down, to value patience, to accept that revelation may come not in a burst of clarity, but in gradual understanding. And there is something deeply restful in that. In a world where human life often feels hurried, the cosmos offers a counterexample. It is vast, patient, and profoundly comfortable with silence. Stars cool for billions of years. Planets drift for eternity without ever finding a sun. Even the universe itself has stretched quietly for almost 14 billion years, a slow breath in progress. To sit with these ideas is to let your own pulse slow, to realize that not everything needs to happen in urgency. The quiet marvels of space remind us that stillness can be a form of strength. As you listen tonight, perhaps you can let this thought sink in. If the universe were composed only of drama, it would have collapsed into noise long ago. What gives it coherence are the long stretches of calm between the bursts. That is why black holes, magnificent as they are, do not tell the whole story. They are the exclamation points, not the paragraphs. The story itself is written in the quiet ink of dark matter, the patient glow of white dwarfs, the frozen drift of rogue planets, and the vast emptiness of cosmic voids. In the chapters ahead, we'll wander through these subtler landscapes. We'll let invisible halos of matter show us how galaxies are cradled. We'll sit with the remnants of stars that continue shining softly long after their fire is gone. We'll listen to the faint afterglow of creation itself and wander through regions of space where silence reigns. Each one will show us, in its own way, why quiet matters, not just as absence, but as presence, not just as background, but as essence. So if the previous chapter was about opening the door to the quiet park beyond the noisy city, then this is the moment we step inside and notice why the stillness is valuable. The night air feels cooler, the sounds around us soften, and in that softened soundscape our senses sharpen. We begin to hear the smaller rhythms that were always there, the hum of crickets, the rustle of leaves, the distant hush of water. In the cosmic park we're entering, the quiet phenomena are not empty at all. They are alive with meaning if we only pause to listen. If you've ever walked through a house at night, perhaps with the lights off, you'll know the strange comfort of being surrounded by structures you cannot see. You know the walls are there because your steps are guided, your path shaped by their presence, even if you can't quite make out their edges. The universe, too, is built upon structures we cannot see. The most important of these invisible frameworks are called dark matter halos. Though halo may be a slightly misleading word. You might imagine a glowing ring or a luminous crown, but these halos do not shine. They are not rings, but vast spherical envelopes, each cradling a galaxy inside, each invisible, yet profoundly powerful. Dark matter itself is one of the great puzzles of science. We can't see it, can't touch it, and so far, we cannot trap it in an experiment. Yet we are certain it exists because of what it does. Galaxies spin in a way that ordinary matter alone cannot explain. Stars at the edges move far faster than they should if only visible matter were holding them in place. It's as if you tossed a stone on a string, and the string held even when it became impossibly long. Something unseen must be tugging, keeping the galaxy intact, preventing it from flying apart. That unseen something is dark matter, and it gathers into halos that are much larger than the galaxies we can actually see. Imagine, for a moment, that you're watching children playing with soap bubbles. The bubbles float, shimmer, and drift, but each one clings to an invisible breath of air inside. Without that breath, the fragile film would collapse. Galaxies are a little like those bubbles. Their stars shine, their gas glows, but beneath it all is the invisible support of dark matter, a breath you cannot see, holding everything in place. Without dark matter halos, galaxies would fall apart, scattering like confetti in a gust of wind. One of the most astonishing facts is just how much dark matter there is. For every ounce of normal matter, the stuff that makes up stars, planets, people, and all the elements of the periodic table, there are about 5 ounces of dark matter. The universe is dominated by the unseen. Our world, our bodies, even our sun are details painted on the surface of something far larger and darker. To live in such a universe is to accept that most of reality is hidden from our senses, and yet without it, nothing familiar would exist. Astronomers have learned to detect dark matter halos not by capturing particles, but by watching light bend around them. Light normally travels in straight lines, but when it passes near something massive, its path curves, like a car skidding around a corner. This bending is called gravitational lensing, and it allows us to map invisible halos by observing how background galaxies appear distorted. It's a bit like walking through a forest where you can't see the wind, but you notice the trees swaying and deduce that air is moving around you. In the same way, the halos reveal themselves not directly, but by how they sculpt the scenery. The halos are not just passive containers. They shape the very birth of galaxies. In the early universe, dark matter gathered first, clumping together under gravity into halos, and only then did ordinary matter, gas, dust, stars, settle into their embrace. In that sense, galaxies are guests in a house built by dark matter. The luminous spirals we admire in telescope images are not free-floating creations, but tenants residing within invisible architecture. This realization reframes our view. Light is not the beginning, but the consequence. The darkness came first, the foundation upon which all visible beauty rests. There is something humbling in knowing that what we see, stars sparkling like distant lanterns, is just the frosting on a vast, unseen cake. Our senses deceive us into thinking that what shines is what matters most, but the universe tells a quieter story. It is the scaffolding, the framework, the skeleton of darkness that allows galaxies to flourish. Without halos, the sky would not twinkle, telescopes would have little to find, and we would not be here to wonder at all. Scientists often describe dark matter halos as ghosts, and perhaps that is the best word. They are not ghosts in the sense of haunting, but in the sense of presence without visibility, influence without form. They are the ultimate unsung heroes of the cosmos, powerful yet quiet, never demanding recognition. They let galaxies shine and then fade into silence, content to remain unseen. In a way, they embody the very theme of our journey tonight, that the universe is not only about what dazzles the eyes, but also about what steadies the heart with invisible constancy. As you picture these halos, imagine the Milky Way itself. The stars we see, including the sun, sit nestled within a halo perhaps 10 times larger than the visible galaxy. We are suspended not just in starlight, but in a vast dark cradle, a cosmic womb that has held our galaxy for over 13 billion years. It will continue to hold it long after our own star grows dim. To rest in that thought is to feel, perhaps, a sense of safety, knowing that even if we cannot see the walls of our cosmic house, they are there, strong and steady, keeping us from scattering into nothingness. Tonight, as you drift, let the image of these invisible architects linger. Picture a galaxy as a glowing lantern, and around it, a vast glass dome, transparent but firm, keeping the flames steady against invisible winds. Or imagine walking through your home in the dark, trusting the walls that guide you even if your eyes cannot. That is what dark matter halos are to the universe. They do not demand applause, they only hold quietly, patiently, for billions upon billions of years. If halos are the invisible houses where galaxies live, then what happens when those houses gather together? Just as neighborhoods grow into towns and towns into cities, dark matter halos connect into something larger, something grander. When astronomers map the universe on scales far beyond any single galaxy, they find a pattern so vast it almost defies belief. Instead of stars sprinkled evenly like sugar on a table, the cosmos is arranged more like a gigantic web. Galaxies are not randomly scattered. They lie along long, thin threads, cosmic filaments, while between those threads lie immense empty regions, the voids. The whole thing resembles a spider's web stretched across an unfathomable darkness, and yet this web is woven not from silk or string, but from shadows, dark matter itself. You can imagine this web by picturing morning dew clinging to a spider's work. At night, you may not notice the web at all, but once sunlight hits, the droplets outline it, revealing its fragile but intricate design. In the same way, galaxies are like drops of dew, glowing along the threads of invisible dark matter. Without those luminous traces, we might never suspect the web exists, and yet it stretches across billions of light years, the largest structure known, a lattice upon which the universe itself is built. The discovery of this cosmic web is one of the quiet triumphs of astronomy. No single telescope image shows it directly. Instead, researchers collected redshifts of galaxies, tiny changes in the light that reveal how far away they are, and plotted them across enormous maps. Slowly, the pattern emerged. Long chains of galaxies, knots where clusters gather and vast emptiness between. It is almost like standing too close to a painting, where the brushstrokes look random, and then stepping back to see a sweeping landscape appear. The universe, viewed from afar, reveals its artistry in the form of a web. There is a kind of poetry in knowing that everything familiar to us, the Milky Way, the Andromeda Galaxy, the great spirals and ellipticals catalogued through centuries, are but beads strung on these invisible threads. Gravity pulls them together, dark matter cradles them, and light simply outlines their position. Without dark matter filaments, galaxies might still exist, but they would float in a sea of disorder. It is the hidden framework that gives the cosmos its structure, its rhythm, its coherence. When cosmologists simulate the universe in computers, starting from the faint ripples of the Big Bang, the web forms naturally. Over billions of years, matter clumps under gravity, drawing gas and stars into its embrace. The resulting filaments look uncannily like neural networks in a brain, as if the cosmos itself is thinking in patterns of light and darkness. It is easy to see why some scientists describe the universe as self-organizing, a kind of natural architect guided by invisible rules. For us, on our small planet orbiting a modest star, this grand web can feel impossibly remote, yet there is a quiet connection. The very atoms in your body, the calcium in your bones, the iron in your blood, were once scattered gas clouds guided by dark matter threads. They condensed where the filaments drew matter together, eventually forming stars that fused those atoms into being. In a real sense, you are here because of the web, a single strand in the endless design. And while this cosmic web might sound like something violent, galaxies colliding, filaments pulling matter together, it is surprisingly tranquil on human scales. The motions are slow, unfolding over billions of years. Imagine watching a glacier flow down a valley. To us it looks frozen, unmoving, but if you could wait centuries, you would see it carving landscapes, reshaping mountains. The cosmic web behaves in the same way. Quiet, almost still, yet profoundly transformative. There is also a lesson here in perspective. If you looked only at a single galaxy, you might think it is an island, isolated in space. But when you see the map of the web, you realize that galaxies are threads in a tapestry, not islands at all. They are connected, woven together, part of a grander pattern. It is much like human life. Each of us may feel separate but step back far enough, and the connections become clear. Threads of family, culture, shared history, weaving us into something larger than ourselves. As you drift deeper into tonight's story, picture yourself floating through this web. Imagine each galaxy as a glowing pearl, strung along invisible strands stretching farther than you can comprehend. Between those strands, wide spaces open like silent halls, places where almost nothing stirs. The scale is beyond imagination, but the feeling need not be overwhelming. It can be calming, like standing in a vast cathedral, the quiet so deep it feels sacred. The cosmic web is the universe's cathedral, its architecture written in shadows and starlight. And here is the most humbling thought. The web is not finished. The universe continues to expand, filaments stretching, voids widening, galaxies sliding slowly along their dark paths. It is a structure still under construction, but one that works in silence, without fanfare, without noise. The threads will continue weaving long after we're gone, long after Earth itself has cooled. To recognize that is to see time itself in a gentler way, not as a rushing current, but as a long, steady tide. So, while black holes may grab the spotlight with their fierce gravity and spectacular effects, the cosmic web remains in the background, patient, steady, unshowy. It is the scaffolding of existence, a masterpiece of quiet architecture. And as you rest tonight, perhaps you can take comfort in knowing that even in the larger scales imaginable, it is not only the loud events that matter. The silent connections, the invisible threads, the softly woven patterns, these are what hold the cosmos together, and maybe, in some small way, they hold us too. Up to now, we've spoken about dark matter as if it were a quiet house holding galaxies or a web stretched across the universe. But there remains an important truth. We have never touched it, never held a piece of it in our hands, never captured a particle of it in a laboratory. Everything we know about dark matter comes from its influence on other things. It is like hearing footsteps in the next room, knowing someone must be there, even though the door stays closed. That raises the question, if this invisible presence shapes the universe, how do we search for it? How do we listen for whispers in a world full of noise? For decades, scientists have built experiments designed to detect dark matter directly. Deep underground, in old mines repurposed as laboratories, massive tanks filled with liquid xenon or argon wait silently in the dark. These detectors are shielded by rock to block out cosmic rays, designed to catch the faintest possible signal of a dark matter particle bumping into an atom. Imagine a cathedral-sized jar of water resting in eternal twilight, with sensors alert for the softest ripple. So far, those ripples have not come. The tanks remain quiet and the whispers remain unheard. Yet the silence itself is meaningful, telling us what dark matter is not, guiding us closer to what it might be. Another approach is to use the sky as a canvas. If dark matter particles sometimes collide with one another, they might release faint traces of radiation, subtle glimmers that telescopes could catch. Astronomers watch the centres of galaxies, especially the crowded heart of the Milky Way. hoping to see a signal that stands out against the background. It is like staring at the surface of a pond at night, looking for the faintest ripple that betrays a fish below. The ripples, if they exist, are elusive, hidden among reflections of starlight and the ordinary movements of cosmic gas. Still, the watching continues, patient and persistent. Some physicists wonder if the particles we are searching for are simply the wrong ones. Perhaps dark matter is not a single kind of particle, but a whole family, like a hidden branch of nature's tree. Perhaps it is something stranger still, not made of particles in the way we imagine at all. To explore this possibility, scientists build new theories, new mathematical frameworks, and test them against the quiet evidence of the cosmos. Each idea is like a whisper offered to the universe. Is it this, or perhaps this? The universe responds not with words, but with the shape of galaxies, the bending of light, the rhythm of expansion. We ask, it answers, but only in hints. There is something beautiful in this uncertainty. Often we imagine science as a story of answers, of problems solved, of mysteries closed. But the truth is that science lives equally in the questions. Dark matter reminds us that not knowing is not a failure, it is an invitation. The mystery itself is part of the wonder, a sign that the universe still holds secrets worth exploring. It keeps us humble, reminding us that even with all our instruments, all our satellites and telescopes, we have only begun to scratch the surface. And perhaps you have felt this in your own life too. Sometimes the things we do not fully understand linger with us longer than the things neatly explained. A song whose lyrics we only half grasp, yet feel deeply. A memory we can't quite place, but which continues to warm us when it appears. Even a dream that fades upon waking but leaves behind an emotional echo. The unknown has its own kind of power, not frightening, but softly compelling. Dark matter is like that dream, vast and ungraspable, and yet gently shaping everything we know. When you think of the search for dark matter, imagine not a race, but a vigil. Picture scientists in mountain tunnels, watching detectors in the silence of rock. Imagine satellites quietly scanning the skies, recording light that left distant galaxies billions of years ago. Picture theorists at their desks, sketching new possibilities in chalk, lines of symbols that hope to catch a shadow. Each of these is a candle left in the dark, a steady flame of curiosity waiting for a response. The waiting may take years, even lifetimes, but the act of waiting itself has meaning, is a way of saying the universe still matters to us, even in its silence. And so, listening for whispers is not only about discovery, it is also about cultivating patience, about learning to be at peace with partial knowledge. For the truth is that the universe may not give up this secret soon. We may live our whole lives without a clear answer, as others before us did, but that does not make the search wasted. On the contrary, it makes the universe feel alive, still mysterious, still capable of surprising us. There is comfort in knowing that wonder will not run out, that there will always be more questions whispering just beyond our reach. As you drift deeper into rest tonight, let yourself imagine being part of that vigil. You're not rushing, not demanding, just waiting, quietly attentive, listening with your whole being for a whisper in the dark. Whether or not it comes, the listening itself has value. The silence itself is a kind of answer. Dark matter may remain hidden for now, but it already shapes us, in the galaxies above, in the atoms within us, and in the patient curiosity that draws us to the night sky. When a star like our sun finishes its life, it does so with a kind of weary sigh. It swells into a red giant, sheds its outer layers, and leaves behind a white dwarf, a glowing ember that slowly cools across billions of years. But not all stars are so modest in their endings. The massive ones, those born with 8 or 10 times the mass of our sun, follow a different script. They burn furiously, die violently, and what remains is neither quiet nor ordinary. Instead of fading into the background, they collapse into something far stranger, a neutron star. A neutron star is, in many ways, the definition of cosmic excess. Imagine compressing the entire mass of the Sun, so vast it could fit over 1 million Earths inside, down into a sphere no bigger than a city, 20 kilometers across, maybe 30 at most. The result is a core so dense that the ordinary boundaries between atoms vanish. Electrons and protons merge, leaving behind a solid mass of neutrons packed shoulder to shoulder, tighter than anything we can replicate on Earth. If you scooped out just a teaspoon of this material and somehow carried it back to our world, it would weigh more than a mountain, more than all the cars on Earth combined. A single spoonful, outweighing a continent's worth of steel. The image is so extreme that it almost feels like a parable rather than a fact. How can the cosmos take something so vast and shrink it into something so impossibly compact? Yet neutron stars are not rare curiosities. Astronomers believe our galaxy alone contains around 100 million of them, each a survivor of a stellar death, each hiding in the shadows unless discovered by the beams they sometimes release. To imagine what a neutron star is, think of a burnt log in a fireplace. Most of the bright flames are gone, but the log still glows with heat, radiating a quiet orange. If you could touch it, you'd feel not only its warmth, but also its stubborn solidity. A neutron star is like that log, except it carries the memory of an explosion. It is not a remnant politely cooling into ash, but the hardened heart of a collapsed giant. It is both dead and alive, a zombie of the cosmos, its surface still radiating, its inner structure forever changed. On their surfaces, conditions defy imagination. Gravity there is so strong that if you stood on a neutron star, you would weigh billions of times more than you do on Earth. A mountain on such a star could be only a few millimeters tall before collapsing under its own weight. Light itself bends around them, curving back like an obedient servant. And time, as Einstein taught us, ticks differently near such intense gravity. A clock on the surface would run more slowly than one in the open void, a reminder that these objects not only warp space but also stretch the fabric of time. And yet, despite this strangeness, there is a kind of stillness to neutron stars. They are not black holes that devour everything nearby. They are not bright stars radiating across light years. They sit between extremes, silent, compact, resilient. They remind us that death in the cosmos is not always a clean ending, but sometimes a transformation into a state we can barely understand. Astronomers often detect neutron stars not by seeing them directly, but by listening to their effects. When one passes through a cloud of gas, it can heat the material until it glows in X-rays. When two of them spiral together, their collision ripples across space as gravitational waves, vibrations in the very fabric of reality. But most of the time, they simply remain invisible, dark spheres adrift, known only to those patient enough to look for subtle clues. In this way, they are much like the quieter moments in our own lives. You may not remember the grand occasions in as much detail as you think. Birthdays, celebrations, achievements. But you might remember a quiet walk with a friend, or a night where the silence itself felt comforting, as if the world had briefly pressed pause. Neutron stars embody that paradox. They are the hushed aftermath of a cosmic catastrophe, yet they carry within them more power than we can fathom. Some neutron stars spin rapidly, sending out beams of light like cosmic lighthouses. We will meet those pulsars in the next session, but even those that do not spin in rhythm are remarkable in their restraint. Imagine a being that has endured an explosion violent enough to outshine entire galaxies, and then, instead of vanishing, simply sits in silence, waiting, glowing faintly, holding itself together with gravity so fierce it bends reality. It is a reminder that endurance too is a form of strength. As you lie here tonight, picture one of these stars, a sphere the size of a city floating light years away, dense beyond comprehension, silent yet unyielding. Around it, space stretches and curves, but the star itself remains steady, a monument to transformation. Like an ancient stone temple weathering storms, it bears the marks of its violent birth, yet continues to stand in stillness. The universe, in its quiet way, is telling us, even after fire and collapse, something endures. So, while black holes may seem like the ultimate finale, neutron stars remind us that there are other endings that are not quite endings at all. They are stars that refuse to die completely, remnants that linger, dense, eerie, and strangely beautiful. In their silence, they hold lessons about resilience, about transformation, and about the ways even the most violent events can leave behind something steady, something enduring, something quietly eternal. If neutron stars are the hushed survivors of stellar collapse, then pulsars are the ones who could not quite stay silent. They are neutron stars, yes, but with a peculiar rhythm, spinning so fast and with such intensity that they beam radiation out into space in regular flashes, like a lighthouse sweeping its light across a foggy sea. Each rotation sends out a pulse, and if Earth happens to lie in the beam's path, our telescopes catch it as a steady tick, tick, tick across the darkness. To picture this, imagine standing on a rocky coast on a misty night. The air is damp, the sea restless, and in the distance a lighthouse turns its great lamp. Every few seconds the beam cuts through the haze, a reassuring sign of presence. You cannot always see the building itself, but the rhythm of its light anchors you, tells you that something solid stands there guiding. Pulsars are like that, but instead of mist, they shine through the fog of space, and instead of seconds, some flash hundreds of times each second. They are lighthouses built not by human hands, but by the collapse of stars. Some pulsars spin at unimaginable speeds. The fastest known rotates over 700 times every second. Picture a city-sized sphere, heavier than our sun, spinning so rapidly that if it were any faster it might tear itself apart. And yet it holds, steady in its rhythm, sending beams of radio waves across light years. To an astronomer, listening to a pulsar is almost like hearing a metronome placed in the sky, a cosmic clock ticking with a precision better than anything we can build on Earth. In fact, some pulsars are so consistent that scientists use them to test the fabric of space-time itself, listening for the faint tremors of gravitational waves passing through. The discovery of pulsars in 1967 was itself almost dreamlike. Jocelyn Bell Burnell, then a graduate student, noticed an odd repeating signal while studying radio data. It was so regular that at first some joked it might be aliens, little green men sending messages, but it was not extraterrestrial intelligence. It was nature itself turning the universe into a beacon. What seemed eerie at first became one of the most profound finds in astronomy. Proof that the cosmos contains clocks far steadier than our own. To imagine how a pulsar works, think back to the old carnival rides where children sit on a spinning platform, and as it spins, objects fly outward if they are not firmly held. Now replace the children with magnetic fields and beams of radiation. As the neutron star spins, its powerful magnetism channels energy into beams, which sweep around like searchlights. The star does not spin forever at the same pace, it gradually slows, but for millions of years it can serve as a beacon, flashing across the void. There is something soothing in the idea of such regularity. The universe often feels chaotic, stars exploding, galaxies colliding, black holes devouring. Yet pulsars remind us that in the midst of turmoil, patterns can emerge. Their steady rhythm is like the beating of a heart, or the swinging of a pendulum. For sailors on a foggy coast, the lighthouse was not just a warning, it was a comfort, proof that there was structure amid the uncertainty of the sea. Pulsars serve a similar role for us. They show us that even in the aftermath of stellar death, order can be found, and they are not merely curiosities. Pulsars help us measure cosmic distances, study interstellar gas, and even test theories of relativity. When two pulsars orbit one another, the way they spiral closer matches Einstein's predictions about energy carried away by gravitational waves. Their regular ticks are like messages written in the margins of the universe, notes left by stars long gone, teaching us lessons across time and space. For all their usefulness, though, they remain strange. To imagine living near one is to imagine a world bathed in radiation, the night sky flashing with relentless intensity. For us, here on Earth, they are mercifully far away, their signals faint but clear, arriving as whispers rather than shouts. They are the right distance for contemplation, not danger. Perhaps you have felt this kind of rhythm in your own life. The sound of a train passing by at night, its wheels clacking in steady repetition. The distant hum of a clock in the living room, even the slow in and out of your own breath when you finally settle under the blankets. Rhythms like these calm the mind. They are anchors against the chaos of thought. Pulsars, in their own cosmic way, offer that same reassurance, steady signals, repeating across unimaginable distances, telling us that even in death, stars can create rhythm. So as you close your eyes tonight, imagine drifting above the sea on a moonless night. The fog is thick, the water dark, and yet every few moments a beam of light cuts through, sweeping across your face. The beam does not stop, it does not falter, it simply continues, steady and unwavering. That is the gift of pulsars: consistency, rhythm, and quiet guidance across the void. They are reminders that the universe is not only chaos, it has its patterns, its steady beats, its quiet lighthouses still shining long after their stars have burned away. If neutron stars are the densest remnants and pulsars are the cosmic lighthouses, then magnetars are the strange monks of the stellar world, silent for long stretches, withdrawn, almost contemplative, until suddenly they erupt in bursts so fierce they can be felt across the galaxy. They are rare, perhaps the rarest type of neutron star, and yet their existence shows us just how varied the afterlives of stars can be. A magnetar is a neutron star with an unimaginably strong magnetic field. To say it is powerful is almost an understatement. The magnetic field of Earth is enough to turn a compass needle. The magnetic field of a fridge magnet can hold up a photograph, but a magnetar's field is 1 trillion times stronger than Earth's. If you could somehow bring a magnetar close to our planet, within even a fraction of the distance between Earth and the Moon, it would erase the data on every credit card, every hard drive, every magnetic strip in the world. Your very atoms would be tugged out of alignment. That is the scale of their power, so intense that ordinary metaphors barely suffice. And yet, most of the time, a magnetar is quiet. It sits in darkness, slowly cooling, hardly distinguishable from other neutron stars. To detect it, astronomers rely on the moments when it suddenly flares, releasing bursts of X-rays or gamma rays as if shouting after long silence. These bursts are not gentle flickers. They can outshine an entire galaxy for a brief instant, sending ripples of energy racing outward. But then the flare fades, and the magnetar retreats into quiet again. It is a cycle of restraint and release, like a monk who speaks rarely, but when he does, his words echo for miles. The reason for these bursts lies in the magnetar's surface and its strained crust. The magnetic field twists and warps the star's skin, creating tension. When that crust gives way, like a tectonic plate snapping, energy floods out in the form of radiation. Astronomers call these events starquakes, a word that captures both their violence and their origin. A quake on Earth might topple buildings. A quake on a magnetar rattles the very fabric of space around it, producing light so fierce it travels across tens of thousands of light years. Despite this ferocity, there is something profoundly quiet about magnetars. They are not constantly roaring. Most of their lives are spent in obscurity, unnoticed, hidden in the dark. Their bursts come unexpectedly, like lightning in a night sky. If you lived near one, it might appear to you as an unremarkable star, until, without warning, it released a storm of radiation. Their nature is both fierce and restrained, silent and sudden, embodying the strange duality that seems to define the cosmos. To bring the image closer to everyday life, imagine a forest in winter. The trees stand bare, the ground is still, and nothing seems to stir. Yet beneath the snow, tension is building, water pressing against ice, roots stretching quietly. Then one day, with no warning, the ice cracks, and a frozen river shifts with a sound like thunder. The forest goes back to silence, but the memory of the crack lingers. Magnetars are like that forest, mostly still but capable of sudden, unforgettable release. The first magnetars were identified only a few decades ago, discovered through sudden flashes of gamma rays that puzzled astronomers. At first, some wondered if these could be the signals of distant civilizations, but the pattern fit too neatly with what neutron stars could do under extreme magnetism. Since then, we've learned to watch the sky for their signatures. When a burst occurs, it is a reminder that even in the universe's quiet corners, energy slumbers, waiting. Their rarity makes them even more intriguing. Out of the 100 million or so neutron stars in the Milky Way, perhaps only a few dozen are magnetars. They are special cases, born from stars whose collapse leaves behind not only dense matter, but also twisted fields of magnetism wound tighter than anything else we know. In the great variety of stellar remnants, they are the outliers, the eccentric relatives who live far away and appear only occasionally, but whose presence cannot be ignored. What makes magnetars especially meaningful in our story tonight is how they balance extremes. They are silent but fierce, dormant but explosive. They embody the idea that the universe is not defined only by its loudest events, but also by the interplay of quietness and intensity. Their silence gives weight to their bursts, just as silence in music makes the crescendo more powerful. If they were always loud, they would simply be background noise. Instead, their rarity makes them stand out, like a single bell ringing across a still valley. For those listening before sleep, perhaps there is comfort in this thought. You may feel that silence is empty, that nothing happens in the quiet stretches of life. But magnetars remind us that silence is not emptiness. It is potential. It is storage of energy gathering quietly, patiently, until the moment it must be released. And when it is, the effect can be transformative. So tonight, as you rest, picture one of these stars. Imagine a sphere no larger than a city, buried in the darkness of space, invisible to the naked eye. Around it, magnetic fields twist and churn, invisible threads of energy stretching far into the void. Most of the time it waits, patient and still, a ghostly ember in a dark sky. But every so often it cracks, releasing a storm that lights up the galaxy. Silent, then fierce. Fierce, then silent again. A reminder that even in the quietest corners of the universe, there lies power beyond measure, waiting in stillness. If magnetars are the monks of the cosmos, fierce and unpredictable, then white dwarfs are more like glowing embers left in a fire long after the flames have gone. They are what happens to stars like our sun, and perhaps that makes them more relatable than the neutron stars or black holes we've just explored. Most stars in the universe do not end with explosions that rattle galaxies. They end more quietly, slipping out of their fiery youth into a long twilight. Imagine sitting beside a campfire. At first, the flames leap high, crackling and sparking, a spectacle of heat and light. But after hours, the fire settles. The logs turn black, their surfaces charred, but underneath a glow remains. soft orange embers, steady but fading, continue to warm the air. They do not roar, they do not shout, they simply glow, gently and persistently, until the last of their heat ebbs away. This is what white dwarfs are, embers of stars still radiant but no longer burning in the wild way they once did. When a star like our Sun grows old, it eventually swells into a red giant, consuming the space around it with an enormous bloated atmosphere. The outer layers drift away into space, forming a cloud of gas that can shimmer beautifully as a planetary nebula. What is left behind once the glowing shell has faded is the dense core. That core, stripped of fuel, no longer fuses hydrogen or helium. Instead, it contracts into a white dwarf, small, hot, incredibly dense, and glowing with residual heat. It is the last stage of an ordinary star's life. Despite their size, no larger than Earth, white dwarfs pack in more than half the mass of their original star. Imagine squeezing the Sun down until it is the size of our planet. The result would be a body so dense that a teaspoon of its material would weigh tons. Not as extreme as a neutron star, certainly, but still far beyond anything we know here on Earth. These stars are reminders that even ordinary endings can leave behind extraordinary remnants. And yet there is a deep stillness to white dwarfs. They no longer generate energy through fusion. They no longer resist collapse with the balancing act that powers young stars. Instead, their glow is simply the last warmth radiating into space, a kind of cosmic memory slowly fading. They will cool for billions, even trillions of years, eventually becoming invisible. But that process is so long that not a single white dwarf in the universe has yet had time to finish it. Every white dwarf we see is still glowing, still whispering of the star it once was. Perhaps this is why they feel so poignant. We live in a culture where endings are often dramatic, marked by fireworks or noise. But in truth, many of the most important endings in life are quiet. A last conversation with someone dear. The final bloom of a flower before winter. The moment when a candle burns down to a small pool of wax. White dwarfs embody this quietness. They show us that fading is not failure. It is part of the rhythm of existence. Astronomers have studied countless white dwarfs, and in their light they see the future of our own sun. Billions of years from now, when our star exhausts its fuel, it too will expand, shed its outer layers, and settle into a white dwarf. Earth, by then, will have been transformed or perhaps lost, but the sun's ember will remain, glowing faintly against the night. When we look at white dwarfs in other systems, we are, in a sense, peering at our own distant destiny. The idea can feel sobering, but also oddly comforting. Endings do not need to be catastrophic to matter. The sun does not need to collapse into a black hole to leave behind a legacy. Its quiet ember will continue, its atoms spread through space, perhaps one day helping to form new worlds. Even in stillness there is continuity. Even in fading there is beauty. For those listening tonight, maybe this resonates on a personal level. Not every season of life ends with a bang. Some end softly, quietly, with a gentle shift that is barely noticeable until you look back. The warmth of childhood memories, the glow of friendships that may no longer be daily but still exist in memory. They are embers, not flames, and yet they continue to warm us long after the fire has burned. White dwarfs remind us of this truth, that what seems like an ending is often just a slower, quieter continuation. So as you drift toward rest, imagine one of these embers floating in the sky. Small, faint, but still glowing with the memory of a life once bright. Around it, the remnants of its former self shimmer in a faint nebula, like smoke drifting away from a fire. And beyond that, the darkness of space stretches on. Yet in that darkness, the ember endures, silent, steady, a quiet death that is not quite death at all. It is persistence, it is memory, it is the universe showing us that even endings can be gentle. When you picture a diamond, perhaps you imagine a ring on a hand, catching the light of the sun, or maybe a crown glittering with the concentrated brilliance of gemstones. Diamonds are, after all, symbols of rarity and endurance, formed under immense pressure deep within the earth. But what if I told you that some of the largest diamonds in the universe are not worn by royalty, nor cut to adorn rings, but drift silently through space, far beyond the reach of human hands? These cosmic diamonds are white dwarfs, crystallizing as they cool, transforming into spheres of pure carbon crystal. The process begins quietly. A white dwarf, glowing fiercely after its birth, radiates heat for billions of years. But eventually the heat dissipates, and the atoms within begin to arrange themselves into a solid structure. Just as water molecules align into crystals when forming ice, the carbon and oxygen within a white dwarf can settle into ordered lattices. Over time, the entire star hardens into a cosmic diamond, a jewel not the size of a ring, but the size of a planet. It may sound fanciful, like something out of mythology, but astronomers have actually observed the signs of this crystallization. By studying the light from white dwarfs, they detect subtle shifts that reveal the presence of solid structures forming within. One such star, named BPM 37093, has been nicknamed Lucy, after the Beatles' song Lucy in the Sky with Diamonds. Lucy is about 50 light-years away and is estimated to be 90% crystalline. In other words, it is a diamond star, billions of times larger than any jewel we have ever held. There is something profoundly humbling about that image. On Earth, diamonds are mined, cut, polished, and treasured as rare stones. In the cosmos, they exist on scales so vast that human jewellery seems like a child's trinket in comparison. Yet unlike earthly diamonds, no one will ever wear these cosmic jewels. They are ornaments not for kings or queens, but for the universe itself, glowing faintly in silence. To bring the idea closer, think of frost on a window pane. At first, the glass is bare, transparent, but as the temperature drops, delicate crystals form, branching into intricate patterns. Each morning, frost is unique, a temporary masterpiece etched by cold. A crystallizing white dwarf is like that window pane, except the frost is made of carbon and oxygen, and the patterns stretch across thousands of kilometers. It is beauty born of cooling, a slow settling into stillness. The timescale is staggering. It takes billions of years for a white dwarf to crystallize fully. Our universe itself is not yet old enough for the first generation of stars to complete this process. We're catching them in mid-transition, like catching a candle halfway through melting. Somewhere in the deep future, countless white dwarfs will have hardened entirely, filling the cosmos with silent diamonds. If the universe were a jewellery box, it would be one too large for us to ever open. Yet even now, the knowledge that such objects exist changes how we see the night sky. The points of light above us may seem like ordinary stars, but hidden among them are remnants that have already begun crystallizing. They sparkle not because of atmosphere or atmosphere alone, but because deep within they are becoming something solid, enduring. The heavens are full of jewels, though invisible to the naked eye. There is a quiet poetry in imagining such stars. They are not violent, not explosive, not demanding. They do not shout for attention like supernovae or roar like quasars. They simply cool, quietly and inevitably, into crystal. They embody patience, the kind of patience that stretches beyond human comprehension. For them, time is not measured in decades or centuries, but in trillions of years. Compared to their endurance, even the longest human story is a flicker. And perhaps that perspective is soothing. Our lives are often filled with urgency, deadlines, the pressure of minutes ticking away. But the universe whispers that not everything is bound by our clocks. Some processes unfold slowly, gracefully, without haste. The crystallization of a star is not rushed, not forced. It simply happens, one atom at a time, until the entire sphere becomes a diamond. We may never witness the completion, but knowing that it is happening brings a sense of calm. Imagine then, as you rest tonight, a vast diamond star drifting through space. It does not glitter in the way Earth's diamonds do, because there is no sun to catch it, no hand to wear it. Instead, it glows softly from within, like a lantern with a quiet flame. Around it, space is silent and time moves slowly. It is beauty without performance, endurance without applause, the kind of beauty that simply exists, whether or not anyone is watching. If there is a lesson in these diamond stars, it might be this: sometimes the most precious transformations are the quietest ones. Just as frost creeps across a window without sound, just as friendships deepen not through dramatic gestures, but through years of small moments, so too do stars become diamonds in silence. They remind us that change does not need to be loud to be profound. Some of the most enduring beauty in the universe arrives not in explosions, but in whispers of crystallization, patient and eternal. We've spoken of white dwarfs as glowing embers and of their crystallization into silent diamonds. But the story does not end there. Even diamonds, given enough time, lose their shine. The final stage of a white dwarf's journey is a star that does not yet exist, not anywhere in the universe. Astronomers call it a black dwarf, a body so cool and so dark that it emits no light, no warmth, no signal of its presence. It is the ultimate ember gone cold, the fire completely extinguished. The thought of such an object is difficult to grasp because our universe is not old enough to contain one. White dwarfs take trillions of years to cool fully. The universe itself is only about 13.5 billion years old. That means we are living in an age of light, surrounded by stars that still shine, still glow, still scatter energy across the darkness. The black dwarfs lie in a future we cannot see, a future that belongs not to humanity or even to Earth, but to the cosmos alone. To imagine a black dwarf, picture a fireplace long abandoned. At first, even after the flames are gone, the embers glow, faint but steady. Later still, the embers fade to dull ash. Eventually, all warmth is gone, and only the outline of wood remains, cold to the touch. A black dwarf is the universe's ash, the residue of stars that once burned bright but now lie silent. Unlike a burnt log, however, it does not crumble. Its density holds it together, a sphere of carbon and oxygen atoms locked in eternal stillness. What does it mean to picture a sky filled with such remnants? In that far future, no twinkling constellations would brighten the night. No galaxies would blaze with clusters of stars. Instead, the heavens would be littered with invisible stones, cold and dark, drifting through a universe that has lost its sparkle. And yet, even that is not an ending so much as a continuation. The atoms within those black dwarfs remain, enduring across time, waiting perhaps for new stories to be written. There is a quiet majesty in contemplating such time spans. We think of history in centuries, sometimes in millennia. Our species itself has existed for only a brief flicker compared to the age of the universe. But black dwarfs remind us that there are futures so distant we cannot truly comprehend them. Trillions upon trillions of years, time so long that even the slow cooling of stars becomes a drama worth noting. In those ages, the universe itself will be transformed beyond recognition, but the remnants of ordinary stars will still persist, stubborn and unyielding in their silence. Some physicists suggest that even black dwarfs may not be truly eternal. Quantum mechanics tells us that over inconceivably long periods, even stable particles may decay, releasing their energy. If that is true, then one day even the black dwarfs will vanish, dissolving into radiation, their atoms unravelling. But those timescales make trillions of years look short. They stretch into numbers so large they lose meaning, where counting itself becomes absurd, and perhaps that is the point. The fate of black dwarfs is not something to solve, but something to sit with. A meditation on endurance, stillness, and the strange patience of the cosmos. In a way, they represent the ultimate expression of quietness. A black hole, dramatic though it may be, still interacts with its environment, still warps and consumes. A pulsar still beams across space, a magnetar still flares. But a black dwarf does nothing. It neither shines nor pulls nor announces itself. It simply exists, dark and silent. And in that, it becomes the purest whisper the universe can make. Bringing this closer to our own experience, think of times in life when all the noise falls away. After a long day, when the conversation ends, when the house grows still, when you lie awake and the night hums with silence. At first, the quiet can feel empty, even unsettling. But if you stay with it, it becomes grounding. It reminds you that not everything needs to be filled with sound, not every moment needs a flame. Sometimes presence alone, quiet and unadorned, is enough. A black dwarf is the universe's way of teaching that lesson. Existence without performance, presence without display. The beauty of this idea is that we will never see a black dwarf. Humanity may not last that long, Earth itself may not last that long, and perhaps no beings will ever be there to witness the first one. Yet they will come, silently, inevitably, as the stars finish their slow fade. The universe does not hurry, and it does not need an audience. Its stories unfold regardless, stretching across timescales we cannot enter, reminding us of our smallness, but also of our connection to a greater whole. As you rest tonight, perhaps imagine that far-off future, a sky not filled with stars but with silence, a cosmos that has grown cold where only dark remnants drift. It may sound bleak, but there is also peace in it, for even when the fires go out, something remains. The black dwarfs, invisible though they may be, are still there, still existing, still holding the memory of the light they once gave. They are not tragedies, but monuments to endurance, statues carved by time itself. And in their silence, perhaps you can find comfort. If the universe can endure through ages of darkness, then so can we endure through the quiet stretches of our own lives. Light fades, warmth ebbs, but existence continues, steady and calm. In the end, even when stars go dark, the story is not finished. It simply shifts into another chapter, one written in silence, patience, and the soft persistence of being. When you think of a planet, perhaps your mind immediately imagines one circling a star, Earth around the Sun, Jupiter with its colourful storms, or distant Neptune tracing its lonely blue path. Planets, in our everyday understanding, are children of stars bound by their gravity, warmed by their light. But not all planets keep that bond. Some are cast adrift, wandering the galaxy without a sun to guide them. These are rogue planets, worlds without homes, travelling silently through the dark. Astronomers have only recently begun to detect these strange wanderers, and already they suspect there may be more of them than stars in our galaxy. Imagine that for a moment, the Milky Way glittering with hundreds of billions of stars, and hidden in the darkness between them, countless unseen planets drifting in silence. They do not glow. They do not announce themselves with light. They are black silhouettes against an already black sky, detectable only when they pass in front of distant stars or reveal their gravity by tugging gently at starlight. Most of the time, they remain invisible, a reminder that the universe is filled not only with brilliance, but also with hidden journeys. To picture a rogue planet, imagine walking along a quiet country road at night. Streetlights vanish behind you, houses grow scarce, and you find yourself surrounded by fields under a starry sky. There is no sound but your footsteps and the occasional breeze. The road continues, but there is no clear destination, only motion through stillness. A rogue planet moves in a similar way, endlessly, without a guiding sun, without a familiar orbit to return to. It travels not in weeks or years, but in millions of years, a lonely path through interstellar space. How do such planets come to be? Some were born with stars but did not remain. In the early chaos of planetary systems, when young worlds jostled for position, gravitational scuffles could fling one away, like a marble knocked out of the circle. Others may have formed in the dark without ever knowing the warmth of a star. However they began, they are now orphans, carrying their atmospheres, mountains and oceans, if they have them, through an eternal night. It is tempting to imagine these worlds as barren and lifeless, frozen solid under the cold of interstellar space. Without a sun, their surfaces would be locked in ice, their skies empty. Yet even in that thought, there is a kind of haunting beauty. A planet coated in frost, mountains glimmering faintly under the light of distant stars, oceans preserved as glass, drifting endlessly, a frozen jewel, unseen, yet still moving faithfully along its path. And yet, the story may not be only one of silence. Some scientists suggest that, under thick blankets of ice, warmed by the faint heat of a planet's own core, there might be liquid oceans. Life on Earth has been found in the strangest of places, around hydrothermal vents in the deep sea, in caves where sunlight never enters, even beneath glaciers where microbes feed on minerals. If life can thrive in those hidden corners here, who is to say it could not also survive quietly on a rogue planet adrift in the dark? For us, here on Earth, rogue planets are invisible companions. They drift through the galaxy alongside us, unseen but numerous, like shadows moving between lanterns. To think of them is to think of loneliness, yes, but also of persistence. They remind us that existence does not require a spotlight. They move forward, endlessly, with no applause, no recognition, and yet they continue. Perhaps you've had a night where you felt detached from everything familiar, walking alone, hearing only your own breath. At first, such solitude can feel isolating, but with time, it becomes peaceful, a reminder that you can move forward even without a guide. Rogue planets embody that same lesson. They do not orbit, they do not circle, they simply go. Their journeys are not circular but open, an eternal drifting into whatever lies ahead. Astronomers sometimes call them interstellar nomads, and that phrase fits. They are wanderers, travellers without permanent homes, yet not without dignity. In the silence of their paths, they mirror something deep in us, the part that longs for freedom, the part that wonders what lies beyond the boundaries of the known. To imagine a rogue planet is to imagine the universe as more than stars and light. It is to imagine the quiet in between, the spaces where motion continues even when the lamps have gone out. So tonight, as you rest, let yourself picture one of these lonely worlds, a sphere of rock and ice floating through endless dark. No sunrise, no sunset, no seasons, only the faint glimmer of faraway stars reflected faintly on icy plains. Mountains stand in silence, oceans sleep beneath frozen shells, and time itself seems to slow. Yet the planet drifts on, steady and patient, through the black corridors of the galaxy, silent, unseen, but enduring. In its persistence, you may find a kind of comfort. The rogue planet does not despair at its solitude. It does not resist its path. It simply continues, an unsung traveller through the night. And perhaps that is its lesson for us, that sometimes life too asks us to keep moving through stretches of quiet, stretches where guidance seems absent. Even then, the journey continues, and even in darkness there can be dignity, beauty, and peace. In the vast family of the universe, most planets are children bound to stars. They circle their parents faithfully, year after year, warmed by their light and kept in orbit by their gravity. But every family has its moments of chaos, and in the early days of planetary systems, chaos was the rule rather than the exception. Imagine a crowded nursery where too many children are jostling for space. Some cling tightly to their parents, others stumble and push, and sometimes one is shoved so forcefully that it tumbles out of the room altogether. This is how many rogue planets are born, not in peace, but in the tumultuous adolescence of young solar systems. In those early days, stars are surrounded by disks of dust and gas, swirling and colliding until planets take shape. The process is messy, full of gravitational tugs and violent encounters. Giant planets may migrate inward, pulling smaller worlds out of stable paths. Two young giants may wrestle, their orbits crossing until one is ejected entirely. The result is a planet without a sun thrown into the void and often cast out into interstellar space. It is not a punishment, nor a conscious exile. It is simply the consequence of gravity's endless negotiations, a dance where not every partner finds a place. Some rogue planets, however, may never have known the warmth of a star at all. In the densest regions of molecular clouds, the cold nurseries where stars themselves are born, small clumps of gas may collapse without ever reaching the mass needed to ignite nuclear fusion. Too small to shine, too heavy to be mere asteroids, they linger as planetary bodies from the beginning, born into solitude. These are the orphans who never had parents in the first place, worlds whose stories began in the dark. Whether ejected or born alone, their journeys are long and lonely. Picture a child lost in a city at night, walking down empty streets, guided only by the faint glow of distant lamps. The city continues on, noisy and alive in other districts, but the child's path is solitary, defined by absence rather than presence. Rogue planets move like that, through a galaxy full of suns, but without belonging to any of them. Their paths are not circles but lines drifting through corridors of blackness where no sunrise will ever come. And yet, calling them orphans should not only evoke sadness, there is also resilience in their stories. Cast out of the nursery, they do not stop existing. They endure, carrying their mountains, their valleys, their hidden cores of heat, onward through space. They may be invisible to us, but invisibility does not mean insignificance. They are proof that life, whether planetary or human, can continue even when the ties we expect are broken. Astronomers suspect there may be billions, even trillions, of these planets adrift in our galaxy. For every star you see in the sky, there could be more planets moving unseen between them, quiet travellers without light to reveal their presence. This means that the Milky Way, which we often imagine as a sea of starlight, is also a sea of darkness, filled with worlds whose journeys go unnoticed. The night sky above you may hold countless hidden planets, drifting past like silent ships without lanterns. In the human heart, there is something deeply resonant about the idea of such orphans. Many of us know what it feels like to be adrift, to lose a centre of gravity, to move through periods where guidance seems absent. The rogue planets are not metaphors of despair, but of perseverance. They continue, they drift, they endure, carrying the quiet dignity of survival. Their story is not of what they lost, but of what they still are. Worlds, complete in themselves, whether or not a sun shines upon them. If you close your eyes tonight, imagine one of these orphans. Perhaps it was once part of a thriving planetary system, orbiting a young star, its skies alive with light. Perhaps in a chaotic moment it was flung outward, past the edge, into the endless dark. Or perhaps it was born into that darkness, knowing no other state. Now it drifts, silent, its path long and unchanging. Its surface may be frozen, its atmosphere thin or gone. But deep within, its core may still glow faintly, heat preserved from its birth, warmth kept like a secret. There is something hauntingly beautiful in that image, a planet that carries its own quiet fire, unseen by any eye, unlit by any star but still existing. like a lantern with no flame, but with the memory of warmth folded into its heart. It may never host life, or it may one day brush close to a star again, captured into orbit. Its destiny is uncertain. What is certain is its persistence. In calling them orphans of the cosmos, we may be tempted to pity them, but perhaps we should also admire them. They are reminders that the universe is full of paths we cannot see, lives lived in silence, journeys unlit but real. And perhaps they whisper to us too that even when we feel unmoored, even when the familiar warmth seems far away, our existence still carries meaning. We too are travellers, and not every journey requires a guiding light to be worth taking. When we imagine life elsewhere in the cosmos, our thoughts often turn toward the warmth of suns. We picture alien forests bathed in light, oceans glittering under distant skies, or strange creatures walking beneath foreign constellations. Light feels essential because here on Earth, it is the foundation of nearly everything we know. Plants weave sunlight into food, animals depend on that food, and even our own rhythms are guided by the rising and setting of the sun. It is natural then to assume that a planet without a star is a planet without life, and yet nature has a way of surprising us. Sometimes life hides in the shadows, sometimes it blooms in places where no sunlight ever falls. On Earth, deep beneath the oceans, there are ecosystems that do not rely on sunlight at all. Around hydrothermal vents, where hot water rich with minerals gushes from cracks in the seafloor, strange communities thrive. Tube worms, blind shrimp, and entire colonies of microbes live on chemical energy drawn from the Earth itself. They exist in darkness so complete that the sun might as well not exist. To them, warmth comes not from the sky above, but from the planet beneath. These deep-sea creatures remind us that life's requirements may be broader than we once believed. Now imagine a rogue planet, adrift in interstellar space, sealed beneath a thick shell of ice. On the surface, the cold would be extreme, the kind of cold that locks oceans into solid stone. But deep below, closer to the core, the story could be different. Heat from radioactive decay or leftover warmth from the planet's birth might keep subsurface oceans liquid. There, shielded from the vacuum of space and insulated by ice, liquid water could remain for billions of years. And where there is liquid water, many scientists believe, there is at least the possibility of life. It is an eerie thought. Entire oceans hidden beneath frozen shells drifting through the galaxy with no sunlight, no day or night, only endless twilight. Yet within those oceans, perhaps microbes swim, feeding on minerals, living slowly but steadily. Their world would be one of silence and pressure, of darkness so total that sight would never evolve. Life would not look like trees or animals. It might resemble the bacteria that cling to vents in our own seas, small but resilient, proof that existence does not require brightness to matter. This vision is speculative, of course. We have never seen life beyond Earth, but speculation itself has value, because it stretches our imagination of what the universe allows. Not so long ago, scientists thought life could exist only in conditions very much like our own. Now, having discovered microbes that live in boiling acid, in frozen deserts, and in radioactive pools, we are beginning to understand that life is a stubborn thing. It adapts, it endures, it takes root wherever it can. If it can flourish in the deepest, darkest trenches of our oceans, why not in the hidden seas of a wandering planet? The possibility adds a strange kind of comfort to the story of rogue planets. At first, they seem like symbols of loneliness, worlds cast adrift, frozen, forgotten. But perhaps some of them are not barren at all. Perhaps they carry secret passengers, tiny but determined, moving through waters that have never seen the sun. If so, then these planets are not merely orphans. They are ark ships carrying life through the vast, starless corridors of the galaxy. Invisible to us, but alive within. It also reframes our sense of home. We think of Earth as special because of its sunlight, its warmth, it's fertile conditions, and it is special. But Earth is also proof that life finds ways in unlikely places. Consider the microbes trapped in Antarctic ice, surviving in darkness for centuries, or the spores carried high in the atmosphere, floating where almost nothing else can endure. These examples whisper to us that life does not need perfection, only possibility. If that is true here, it may be true out there as well. For you listening tonight, perhaps this thought feels like a quiet reassurance. Even in your own life, you may have faced stretches that felt like darkness, periods when warmth seemed distant, when guidance was gone. Yet even in those times, something in you endured. Some inner fire kept alive beneath the surface. You may not have seen it, but it was there, keeping you moving forward. Rogue planets, with their hidden oceans, mirror that resilience. They teach us that life does not vanish in the dark. It simply adapts, waits, and continues. So as you drift toward rest, imagine one of these planets passing silently through the galaxy. On its surface, ice stretches for miles, cold and still. Above it, the stars shine faintly, uncaring, distant. But deep within, far below the ice, a hidden ocean stirs. Perhaps it is filled with nothing more than microbes, tiny sparks of persistence. Perhaps it holds creatures we cannot even imagine. Whatever lives there will never see the stars, will never know a sunrise, and yet it will endure quietly as the planet continues its endless journey. The idea may be speculative, but it is not empty. It is a reminder that the universe is vast, and its stories are stranger and gentler than we often assume. Life may not be a rare flame, dependent on perfect conditions. It may be more like a stubborn ember, glowing in places we least expect, even on worlds without suns, and in that possibility, there is wonder enough to dream by. Every night, when you look at the sky, you are looking into the past. The light from the moon takes only a second to reach you. The light from the sun takes 8 minutes, and the light from the nearest stars may take years. In this way, the night sky is not just a ceiling above you, but a memory. It holds the record of things long gone, carried faithfully across space and time. But if you could peel back the layers of starlight, going farther and farther into the past, you would eventually reach something even more ancient. A faint glow, stretched thin by billions of years of expansion, yet still surrounding us today. Astronomers call it the cosmic microwave background, but you might think of it more simply as the universe's oldest light. This light was born when the universe itself was very young, just 380,000 years after the Big Bang. To us, that sounds like a long time. To the cosmos, it was the blink of an eye. A moment so close to the beginning that it feels almost like hearing the first notes of a song. Before that time, the universe was too hot, too dense, too turbulent for light to travel freely. Photons, the particles of light, were trapped in a fog of plasma, bouncing endlessly off charged particles. But as the universe expanded and cooled, the fog cleared. At last, light could move unhindered, setting off on a journey that would never end. That first great exhale of photons is what we now see as the faint microwave background, still washing over us more than 13 billion years later. To imagine it, think of sitting near a fire on a cold night. Even after the flames die down, long after the logs have collapsed into ash, you can still feel a faint warmth on your skin. The heat lingers, proof that the fire once burned bright. The cosmic microwave background is like that warmth, an afterglow of a fire that shaped the universe itself. It does not blaze like starlight, but it is there, faint but steady, a quiet reminder of beginnings. Astronomers discovered this light in the 1960s almost by accident. Two engineers, Arno Penzias and Robert Wilson, were testing a radio antenna when they detected a persistent hum. They cleaned the instrument, chased away pigeons nesting in the dish, and tried everything they could to eliminate the noise, but the hum remained, coming not from Earth, but from the sky itself, from every direction at once. What they had stumbled upon was the background radiation of the universe, a whisper left behind by the Big Bang. It was as if the cosmos had been trying to speak all along, and at last someone had stopped to listen. Since then, astronomers have mapped the cosmic microwave background in exquisite detail, using satellites like COBE, WMAP, and Planck. What they found was astonishing. The light is almost perfectly uniform, the same in every direction, but with tiny ripples, minute variations in temperature only millionths of a degree apart. Those ripples are the seeds of structure, the first outlines of galaxies and clusters, faint fingerprints of everything that would one day exist. In those patterns of warmth and coolness, we see the origins of the cosmic web, the scaffolding of stars and voids. There is a quiet grandeur in that knowledge. You and I, the earth beneath us, the stars above us, all of it traces back to those faint ripples in the universe's first light. Without them, matter would not have clumped, galaxies would not have formed, planets would not have emerged, and we would not be here to wonder. The background glow is not just a relic, it is a memory of possibility, a record of the universe's first gentle attempt at structure. For you listening tonight, perhaps there is comfort in imagining this glow. It is everywhere, invisible to your eyes but present nonetheless. Every second of every day, microwave photons from the dawn of time pass through you, brushing your skin, whispering across the room. You cannot see them, but you're bathed in them, just as the earth is bathed in sunlight. Only this light is older, softer, more patient. It does not illuminate in the ordinary sense, but it surrounds us with history, a cosmic lullaby humming beneath all things. And maybe that is why the cosmic microwave background fits so well with tonight's journey. It is not loud or dramatic. It is not a spectacle like a supernova or a black hole. It is subtle, persistent, nearly forgotten if not for the instruments built to hear it. Yet it tells the deepest story of all, the story of beginnings, the story of how everything came to be. Its presence is a reminder that the universe has memory, that the silence of space is not emptiness, but filled with echoes of its own birth. So, as you prepare to rest, picture the sky not just as a tapestry of stars, but as a great dome filled with invisible warmth, the leftover glow of creation itself. The stars are bright embers, yes, but beneath them, woven through the fabric of space, is a softer light, ancient and enduring. You do not need to reach for it. You're already within it, wrapped in its embrace like a blanket that has covered the universe since its earliest days. And as you drift into sleep, perhaps you can let that thought settle, that even in darkness, you're never apart from light. The oldest light of all is still here, still surrounding you, still whispering across the night. When astronomers first mapped the cosmic microwave background in detail, they were astonished not only by its uniformity but also by its imperfections. Across the vast canvas of the sky, the temperature was almost exactly the same everywhere, yet not perfectly so. There were tiny ripples, fluctuations no larger than a few millionths of a degree. At first glance they might seem trivial, too faint to matter, but in those faint patterns lay the blueprint of everything. The galaxies, clusters, stars and planets that would one day populate the universe. To picture what those ripples meant, imagine a baker kneading dough. At first the dough looks smooth, but hidden within are small irregularities, tiny air bubbles, uneven folds. When the bread is baked, those imperfections expand, shaping its texture and flavour. Without them, the loaf would be flat and lifeless. The universe worked in a similar way. The ripples in the background light were the unevenness that allowed gravity to begin its work, pulling slightly more matter here, slightly less there, until structure began to emerge. Without those tiny differences, the universe would have remained a smooth fog forever, With no galaxies, no stars, no life, it is remarkable to think that something so small could lead to something so vast. A fraction of a degree difference in temperature spread across the early cosmos became the deciding factor in whether you and I would exist. If the background radiation had been perfectly smooth, matter would have spread evenly, and there would be no clumps, no stars, no planets. The night sky would be a dark, uniform soup. The fact that the CMB is almost smooth but not quite is one of the great strokes of cosmic balance. The universe seems to thrive on imperfection. Astronomers study these ripples with the care of archivists reading ancient manuscripts. Satellites like Planck measured them so precisely that we can now trace the early conditions of the cosmos with astonishing accuracy. From the size and distribution of the ripples, scientists can calculate the age of the universe, the proportions of matter and dark energy, even the geometry of space itself. Each tiny fluctuation is like a letter in the universe's diary, spelling out secrets of its origin, and all of this from variations so subtle that they seem more like whispers than declarations. Perhaps you have seen something similar in your own life. How small beginnings can blossom into unexpected outcomes. A single conversation that leads to a friendship, a chance encounter that alters the course of years. Even the small imperfections in handmade objects, a pottery cup with a slight curve, a quilt with uneven stitches that make them beautiful and memorable. The ripples of the CMB are like that. They are the universe's uneven stitches, and because of them, the cosmos has texture. If you could have stood in that early universe when the CMB was first released, you would not have seen galaxies or stars. You would have seen a glowing fog uniform to your eyes, endless in every direction. Yet hidden in that fog were the ripples, faint differences that gravity would amplify over billions of years. The places just slightly denser than average became the seeds of galaxies. Matter gathered there, forming stars and planets. The places slightly emptier became the great voids we now see between clusters. In time, the grand tapestry of the cosmic web unfolded, all from those subtle beginnings. There is a kind of comfort in that thought. The universe did not require loud, dramatic forces to begin creating structure. It began quietly, with almost invisible differences. Over time, those differences grew, shaped by gravity, until the galaxies shone. It is a reminder that small things matter, that quiet beginnings can hold immense potential. As you drift tonight, you might think of your own life as filled with ripples. The words you speak, the choices you make, the small acts of kindness that ripple outward, often unnoticed at first, but in time shaping patterns larger than you imagine. Just as the universe did not need fireworks to create galaxies, our lives do not always need grand gestures to create meaning. Sometimes the faintest ripple is enough. Astronomers sometimes call the CMB a baby picture of the universe, the earliest portrait we have, but perhaps it is also something else. Not just a picture, but a promise. A promise that small variations, far from being flaws, are the seeds of beauty. Without ripples, no galaxies. Without unevenness, no stars. Without imperfections, no life. So, as you rest, imagine those ripples spreading across the early cosmos. Imagine them like brush strokes on a vast canvas, so faint they are barely visible, yet destined to become spirals of stars and glowing worlds. Imagine the way a baker's hands fold dough, tiny imperfections shaping the loaf. Imagine the way an artist's brush leaves uneven marks that give character to a painting. And let it soothe you to know that imperfection, far from being a failure, can be the very source of creation. The galaxies we see today, the Milky Way, Andromeda, all the countless others, are not accidents. They are the grown forms of those tiny ripples stretched and sculpted by time. When you look at the night sky, you are seeing the echoes of the universe's first whispers magnified into brilliance. And that means that in every star's light, in every planet's orbit, in every quiet corner of the cosmos, there is a trace of that ancient unevenness, a trace of the ripples that became galaxies. As astronomers studied the ripples of the cosmic microwave background, mapping them with ever greater precision, they began to notice something unusual. Among the faint patches of warmth and coolness scattered across the sky, there was one region that seemed colder and larger than expected. It wasn't just a small fluctuation like the others. It was a vast patch, hundreds of millions of light years across, noticeably different from its surroundings. They named it simply the cold spot. At first glance, it might not seem remarkable. After all, the CMB is filled with variations. But the cold spot stood out. Its size and depth were difficult to explain using ordinary chance. Some scientists argued that it could indeed be a statistical fluke, just a roll of the cosmic dice that happened to produce a bigger patch than usual. Others suggested that it might be linked to an enormous void, a region of the universe relatively empty of galaxies, which could make the CMB appear cooler when its light passes through. Still others allowed themselves to wonder whether it hinted at something more exotic, perhaps even evidence of another universe brushing against our own. The idea of a cold spot shaped by a void is itself fascinating. Imagine light as a traveller moving across the universe. When it passes through regions full of matter, galaxies, clusters, dark matter halos, it is tugged this way and that by gravity, like a hiker weaving through crowded streets. But when it crosses a great void, there is little to pull on it, and its energy shifts slightly. To us, the result is that the light looks colder, dimmer, stretched. If the cold spot is truly the imprint of such a void, it means we are looking not only at the afterglow of the Big Bang, but also at the fingerprints of cosmic emptiness layered upon it. And yet, the void explanation may not be enough. Studies of galaxies in that region suggest that while there is a large underdensity, it may not fully account for the cold spot's depth. That leaves open the possibility that something stranger is at play. Some theorists have suggested the cold spot could be the scar of a collision between our universe and another bubble of space-time in the earliest moments of inflation. If true, it would be the faintest of handshakes across realities, a trace of a multiverse beyond our reach. It is tempting to let the imagination soar here, to picture other universes pressing gently against ours, leaving behind quiet marks like ripples on a pond. But even if the cold spot is nothing more than chance, even if it is simply a statistical quirk, there is still wonder in it, because chance too is part of the fabric of the universe. Flukes happen, imperfections appear, and sometimes they lead to new beauty. To bring this closer, think of walking along a beach. Most of the sand is fine and even, smoothed by the waves. But here and there, you notice patches that stand out. Clusters of shells, unusual patterns drawn by the tide. Perhaps they are nothing more than chance, yet you pause to notice them. The cold spot is like that. A patch in the great sand of the cosmos, drawing our eye because it differs from the rest. Whether it has deep meaning or not, it reminds us to look closely, to wonder at variation. There is also something soothing about the way the universe presents such puzzles. It does not shout its secrets at us. It leaves them subtly, faintly, requiring patience and curiosity to uncover. The cold spot is not a firework exploding in the sky. It is a soft anomaly, a quiet whisper on the oldest light, inviting us to lean closer and listen. And perhaps this is the point. The cold spot is not just about what it is, but about what it represents. That even in the most studied, most ancient layer of the cosmos, mystery remains. We can map, measure and model, and still there will be places where certainty falters. Those places are invitations, not failures. They remind us that wonder is not exhausted, that discovery is ongoing. For you listening tonight, there may be a personal resonance here. Life too has its cold spots, moments or memories that feel different, anomalies in the smooth fabric of days. Sometimes they're coincidences, sometimes they're shaped by deeper causes, But either way, they invite us to pause, to ask, to notice. Not every irregularity needs to be explained away. Some can be cherished simply as reminders that life is not perfectly uniform, that its texture is made richer by its unevenness. So as you drift into rest, imagine the cold spot in the sky. A vast, quiet patch, invisible to your eyes, but present in the background light that surrounds us all. It is neither threatening nor urgent. It is simply there, a cool hush in the cosmic afterglow, whispering of chants, of voids, perhaps even of other worlds. Whether it is profound or ordinary, it is part of the universe's lullaby. And in that lullaby there is space for curiosity, for imagination, and for peace. When we think of the universe, it is natural to imagine stars, galaxies, and glowing spirals stretching across the night. Our minds are drawn to what shines. Yet if you step back and look at the cosmos on its larger scales, you will discover that it is not the light but the darkness that dominates. Between the filaments of galaxies and clusters are spaces so vast, so empty, that they dwarf every glowing object we have ever seen. These regions are called cosmic voids, and they are among the most mysterious features of the universe. A void is not simply a gap between a few stars. It is a cavern in space that can stretch hundreds of millions of light years across, containing almost nothing at all. If you were to travel into one, you might cross distances greater than the span of entire superclusters without encountering more than a handful of galaxies. To give it perspective, imagine a desert, wide and silent. Even in the emptiest desert on Earth, you will find rocks, grains of sand, perhaps a solitary plant clinging to survival. In a cosmic void, even that comfort disappears. The emptiness is not measured in footsteps, but in light years, in expanses so silent they strain the imagination. It is difficult to hold such scales in the mind, so let us try an image closer to home. Imagine entering a grand cathedral at night. The doors close behind you, and the air feels cool, the silence so deep you hear your own breath echo. A few candles flicker at the far end, their light swallowed by the vastness of stone and shadow. The space is not frightening, but humbling. You feel small, not because the cathedral is hostile, but because its silence and scale remind you of how much greater it is than you. Cosmic voids are like those cathedrals, but on scales where galaxies are the candles, few and faint, scattered far apart. For a long time, astronomers did not know voids existed. When we looked at the sky through telescopes, it seemed filled with stars and galaxies. Only with detailed surveys, mapping the three-dimensional distribution of galaxies across space, did the pattern emerge. What at first appeared random revealed itself as structured. Galaxies strung along filaments and walls, knots of clusters where threads crossed, and between them, enormous bubbles of emptiness. The universe, it turned out, was more like a sponge than a uniform soup. Matter concentrated on the surfaces, nothing in the hollow spaces within, and yet voids are not entirely nothing. A few galaxies do drift inside them, though faint and rare. They are like lanterns left behind in abandoned rooms, flickering bravely against the dark. These void galaxies are often unusual, dimmer, with fewer stars, sometimes irregular in shape. They live apart from the crowded hubs of cosmic life, evolving in solitude, shaped by isolation rather than by the jostling of neighbours. Their very existence tells us that even in the emptiest places, matter finds a way to persist. To imagine living on a planet in such a galaxy is to imagine a sky with fewer companions. Nights would be dark, the horizon of stars sparse, the familiar arch of a Milky Way absent. Your world would still orbit its sun, your sky still marked by constellations, but the great river of starlight we see here would be missing. The universe would feel emptier, more silent, more alone. And yet perhaps that silence would not be bleak. Perhaps it would be calming, a reminder that space is not always crowded, that solitude too has its place in the cosmic story. Astronomers study voids not only for their beauty, but also for the secrets they may hold. Because voids contain so little matter, they expand faster than denser regions, offering clues about dark energy, the mysterious force that drives the universe's accelerating expansion. In their emptiness, voids become laboratories, natural experiments that allow us to measure the shape and speed of the cosmos itself. They are not empty of meaning, even if they are nearly empty of matter. There is also a philosophical weight to them. In a universe where we instinctively seek light and structure, voids remind us that absence is part of design. A painting is not only brushstrokes, but also the spaces between them. Music is not only notes, but the silences that make the notes meaningful. Life itself has its pauses, its stretches of stillness that give shape to experience. The cosmic voids are those silences on the grandest stage. They do not threaten, they simply are, vast empty rooms where the architecture of the universe breathes. As you listen tonight, perhaps you can let that image settle into you. Picture yourself stepping into one of these voids, not as an astronaut with machines, but as a drifting presence, weightless and unhurried. Around you, nothing stretches in every direction, a silence deeper than any cathedral, a stillness beyond deserts or oceans. Here and there a faint galaxy glimmers, far away, like a candle flickering in an abandoned hall. The emptiness is immense, but it is not hostile. It is simply vast, a reminder that space has room for everything, including silence. And maybe that is what voids teach us, that silence is not lack, but presence of another kind. Just as the pauses in music let melodies breathe, the emptiness in the universe gives galaxies their stage. The stars may dazzle, but it is the space between them that makes their beauty possible. The cosmic voids are those spaces, those pauses, those vast empty rooms in which the drama of the universe unfolds. If the vast emptiness of cosmic voids is like stepping into an abandoned cathedral, then their role in the universe is more than simply architectural. They are not just empty spaces left over after galaxies gathered elsewhere. They actively shape the story of cosmic expansion. In their hollowness lies a clue to the greatest mystery of all, the quiet force that drives the universe apart: dark energy. At first, this may seem counterintuitive. How can nothing shape something? How can emptiness direct the growth of everything? But this is the paradox of the voids. Because they contain so little matter, they are freer than other regions. While galaxies and clusters hold one another tightly with gravity, voids experience less resistance. They expand more rapidly, their emptiness growing as the fabric of space stretches. In this way, they are amplifiers of dark energy, places where the universe's quiet acceleration can be seen most clearly. Imagine for a moment a piece of music. The notes matter, of course. The violins swell, the piano's resonance. But the pauses matter just as much. Without silence between them, the sound would collapse into noise, unshaped and overwhelming. The pauses give the notes space to breathe, to stand out, to carry meaning. The voids are like those pauses. They do not glow like galaxies, but they allow the rhythm of expansion to be heard more clearly. In their silence, the music of the universe gains its structure. Astronomers measure voids by mapping galaxies, tracing where they are absent as carefully as where they are present. It is like sketching a pattern not by drawing the lines themselves, but by shading in the gaps. When they measure how these voids expand, they compare them to predictions of cosmological models. The results tell us how quickly the universe is stretching, how dark energy pushes against the pull of gravity. It is humbling to think that the most profound clue to the fate of everything, the ultimate trajectory of time and space, comes not from what is there, but from what is missing. You may have experienced something like this in your own life. Sometimes it is not the loudest words or the busiest moments that shape you, but the silences. A pause in conversation where meaning lingers. A quiet break in the day where clarity arrives. Even the gaps in memory, the spaces where details fade, often give shape to the story more than the facts themselves. The universe works in the same way. The silence between the notes carries as much weight as the notes themselves. When cosmologists simulate the universe, they find that voids are like great bubbles growing within the cosmic web. They start as slight underdensities in the early universe, and gradually balloon out as expansion accelerates. Galaxies at the edges of voids are pulled outward, like dust clinging to the surface of a growing soap bubble. Over time, the voids dominate the landscape. In the far future, they will be even larger, the filaments stretched thinner, the galaxies more isolated. The universe will look more like lace than a sponge, delicate and vast, with emptiness the prevailing feature. This vision can feel unsettling if you dwell only on the absence, a future where everything grows more distant, where stars retreat, where galaxies become lonely. But there is another way to see it. Emptiness is not a void of meaning. It is a space for reflection, for possibility. Just as music requires silence to let its beauty breathe, so too does the cosmos require voids to let its expansion unfold. Without them, the universe would not grow into the shape we see. On Earth, we often rush to fill silence, to fill space, as though emptiness is something to be feared. But sometimes silence is the gift, the breath between phrases, the space where understanding can settle. The cosmic voids remind us of that. They are the grandest silences of all, woven into the very fabric of the universe, not as mistakes, but as structure. They are the spaces between the notes of creation. As you rest tonight, perhaps imagine yourself floating at the edge of such a void. Behind you, a cluster of galaxies glows faintly, bound together like a handful of candles. Before you stretches darkness, not hostile, not frightening, but open. A space so vast it feels like eternity itself. You drift there, listening not to sound but to the silence, and you realize that the silence is part of the music. It is the universe breathing out, expanding into stillness. And in that breath, in that quiet expansion, lies the story of everything that will ever be. When you look at the night sky, it is tempting to think of it as scattered, stars tossed randomly across blackness like salt across a table. But step far enough back and a pattern emerges, one so large we cannot see it with our eyes but only with the careful maps of astronomers. Galaxies are not spread evenly. They are arranged along filaments, long glowing threads stretched across the universe, weaving a structure so vast that it resembles lace. Between those filaments lie the voids we have just wandered through, the empty rooms of creation. Together, the threads and the gaps form the cosmic tapestry, a pattern where both presence and absence matter. The filaments are the highways of galaxies. Along them, matter flows, pulled by gravity into chains that span hundreds of millions of light years. At their intersections, knots form, clusters of galaxies bound tightly together. It is in these knots that the richest regions of the cosmos exist, crowded, luminous, buzzing with activity. Yet those knots would mean little without the emptiness around them. The filaments stand out only because the voids surround them, like rivers carving their way through a plain. The contrast between full and empty, light and dark, is what makes the pattern clear. Think of lacework. A piece of lace is beautiful, not only because of the threads that form flowers and spirals, but because of the spaces between them. The gaps are as important as the stitches. Or think of woven cloth, where the pattern emerges only because threads cross over and under, leaving spaces for light to filter through. The universe works in the same way. The galaxies are the stitches, the filaments the threads, but the voids are the spaces that let the design breathe. Without one, the other would lose its meaning. When scientists simulate the growth of the universe, they see this tapestry emerge naturally from the ripples of the cosmic microwave background. Where matter was slightly denser, filaments grew, pulling more material toward them. Where matter was slightly thinner, voids expanded, pushing galaxies away. Over billions of years, the universe stretched into a pattern that is neither fully ordered nor completely chaotic. It is balanced, intricate, a harmony between threads and gaps. To bring the image closer, think of standing in a forest and looking up through the branches. The canopy above is not a solid sheet of green, nor is it empty. It is a pattern of leaves and sky, of branches and openings, both parts shaping the view. Or think of listening to a choir. The voices carry the melody, but it is the rests, the spaces between breaths, that give the song its rhythm. The cosmic web is the universe's choir, the filaments its voices, the voids its rests. Together they create the music of structure. This balance carries lessons too. In our lives, we often value only the visible achievements, the threads, the stitches, the things that shine. But the gaps matter as well. The pauses in a busy day, the spaces between conversations, the quiet moments where nothing seems to happen, but where meaning gathers. The cosmos itself is built on such a balance. Light and darkness, presence and absence, activity and stillness. It whispers that we need both, that the threads only stand out because of the gaps around them. The cosmic tapestry also humbles us with its scale. The Milky Way, vast as it feels to us, is just a single bead on a thread, strung alongside countless others. From afar, it would be no more than a fleck of light on a filament stretching across unimaginable distances. And yet, from that fleck, we're able to look out and notice the design. We are both part of the pattern and observers of it, both threads and witnesses to the weaving. As you listen tonight, imagine yourself drifting through this web. You float along a filament, galaxies glowing around you like lanterns strung on a line. Ahead, you see a knot where dozens of filaments meet, a bright cluster sparkling like a jewel in the fabric. Then you drift outward, past the last galaxies, into the void. The contrast is striking. Threads alive with light, gaps silent with emptiness. And yet together they form something beautiful, something whole. This is the universe's great lesson, that wholeness is not only about fullness, it is about balance. Just as music requires both notes and rests, just as art requires both lines and blank space, just as life requires both activity and pause, so too does the universe require both filaments and voids. The threads without the gaps would blur into uniformity. The gaps without the threads would vanish into nothing. But together they weave the story of existence. So as you prepare for rest, perhaps let this thought settle. You, too, are part of that tapestry. You're a thread in the web of life, woven into families, friendships, and communities. And you're also part of the spaces, the silences, the pauses that give shape to your days. Neither diminishes the other. Both are necessary, both beautiful. The cosmos, vast and intricate, reminds us of this balance. Its design is not loud or showy. It is subtle, delicate, and enduring, a woven cloth of light and silence stretched across eternity. Every galaxy begins its life as a chorus. In the early universe, matter clumped into filaments, gas streamed inward, and stars flared into being like voices joining one after another in song. The Milky Way itself has been singing for billions of years, producing new stars in its spiral arms, their light adding notes to the galactic melody. Yet not all galaxies continue forever in this way. Some, over time, grow quiet. They stop forming new stars, leaving only the older ones to glow faintly. Astronomers call them quiescent galaxies, but the phrase I like to imagine is simpler: galaxies that have stopped singing. To picture such a galaxy, think of an orchard in spring. Trees bloom, blossoms spill fragrance into the air, bees move from flower to flower. That is a galaxy in its youth, bursting with star formation. Now imagine the same orchard centuries later. The trees still stand, their trunks sturdy, their branches stretched wide, but no new blossoms appear. The orchard is not gone, but it is quieter, its season of flowering over. Quiescent galaxies are like that orchard. They still exist, their stars still shining, but they are no longer blooming. Why does this happen? Galaxies need raw material, clouds of cold gas, to create new stars. Over time, they can lose this supply. Perhaps it is used up in great bursts of star formation, or heated and blown away by powerful winds from supernovae and black holes. In some cases, the environment plays a role. Galaxies clustered together may strip gas from one another in their crowded dances, leaving some starved of fuel. Once the gas is gone or too hot to condense, the galaxy falls silent. No new stars emerge. The song pauses, perhaps forever. At first, the sight of such galaxies feels melancholy. They glow faintly, often red in colour, their light dominated by old stars nearing the ends of their lives. Where young galaxies shimmer blue with hot new stars, these quiescent ones carry the hues of twilight. They are the autumn leaves of the cosmos, warm in tone but tinged with finality. Astronomers sometimes call this the red sequence, a way of describing galaxies that have aged into quiet maturity. And yet, there is beauty in them still. A galaxy that has stopped singing is not lifeless. Its older stars still shine, each one carrying its own long history. Some may have planets, some may host quiet remnants like white dwarfs or neutron stars, each telling its own story. The galaxy's structure, its spiral arms faded or its elliptical body smooth, remains a monument to what once was. Silence in music does not erase the notes that came before. It frames them, gives them weight. In the same way, a quiescent galaxy is not a failure but a pause, a reminder that even in the cosmos, blooming cannot last forever. Perhaps you've experienced something similar in your own life. A family home once full of voices that is now quiet. A place once bustling with laughter that now holds only echoes. At first, the silence may seem sad, but with time, it becomes gentle, reflective, filled with memory rather than absence. Quiescent galaxies embody that same feeling. They are not tragic ruins. They are elder statesmen of the universe carrying the dignity of age. The Milky Way too will one day fall silent. For now, it still formed stars in its spiral arms, though not as vigorously as in its youth. But in billions of years its gas will thin, its fuel exhausted, and it too will join the red sequence. Our galaxy, which now sparkles with blue-white stars and vibrant nebulae, will mellow into a quieter glow. The thought is sobering, but it also ties us into the larger rhythm of cosmic life. Just as stars have their cycles of birth and death, so too do galaxies. To imagine a quiescent galaxy is to imagine a place of stillness. Picture a vast elliptical galaxy, its stars spread evenly, glowing softly in red and gold. No nebulae flicker in its heart, no bursts of star formation light up its edges. Instead, it is filled with mature stars, steady and calm. It is not a place of beginnings, but of continuity. The music has slowed, but the harmony remains. As you rest tonight, perhaps you can find comfort in this cosmic quiet. We live in a culture that prizes constant growth, constant productivity. But the universe shows us that stillness has its place too. A galaxy that no longer makes stars still contributes to the beauty of the sky. Its light still travels across space, reaching us after billions of years. Silence too is a form of presence, and in that silence, there is space to reflect, to remember, to rest. So think of these galaxies that have stopped singing, scattered across the cosmos like orchards in autumn. they are not less beautiful for their silence. If anything, their stillness adds depth to the cosmic song, reminding us that every melody has pauses and every life has seasons. They whisper that there is grace in slowing down, and that even when the blossoms fall, the tree remains. When we look at the night sky, we are often dazzled by its brilliance. The Milky Way arches overhead, a river of light flowing across the darkness. Each pinprick of brightness feels eternal, as though the stars have always been and always will be. But nothing in the universe lasts forever, not even starlight. In quiescent galaxies, we see a glimpse of the future, a time when the supply of raw gas has been exhausted, when the cosmic nursery has closed its doors, and when no new stars will be born. What remains is a population of old suns, glowing faintly, slowly dimming into memory. These galaxies glow redder than their younger cousins. That colour is not symbolic only, it is the physics of aging. Young, massive stars shine blue, burning hot and short-lived. But once star formation halts, these giants fade quickly, leaving behind only smaller, cooler stars. Over billions of years, the galaxy's palette shifts, becoming dominated by the red and orange light of long-lived stars. To the eye of an observer, such a galaxy would resemble a field in late autumn. The blossoms are gone, the green of spring replaced by gold and rust. There is still beauty, but it is a beauty of endings rather than beginnings. Our own Milky Way still sings, though its song has slowed. It continues to form stars in its spiral arms, though less vigorously than in its youth. One day, however, its gas reserves will thin. The great clouds that now sparkle with newborn suns will dissipate, their fuel spent. Our galaxy will mellow into quietness, joining the red sequence like so many before it. The thought is sobering, yet not tragic. It is part of the rhythm of the cosmos, a rhythm we are privileged to witness while the music still plays. To imagine the future of starlight is to imagine the universe itself aging. In the far future, galaxies across the cosmos will grow quiet one by one. The blue-white stars will vanish, leaving only the steady embers of long-lived red dwarfs. Eventually, even those will fade, replaced by white dwarfs, neutron stars, and black holes. The universe will not vanish suddenly. It will dim slowly, like the fading glow of a fire as the last coals burn down. There is a sadness in this vision, but also a peace. For what is fading but another form of completion? Think of twilight. At the end of a day, the sky deepens into shades of amber and violet. The sun no longer shines, but its memory lingers in the air, soft and gentle. The day's work is done, and the evening invites rest. Quiescent galaxies are the twilight of the cosmos, glowing with the light of old stars, their songs softer but no less meaningful. They remind us that not every chapter needs to be filled with new beginnings. Some chapters exist to savour what remains. The fate of starlight also teaches us humility. We live our lives in the midst of abundance, our sky filled with stars, our galaxy alive with light. But this abundance is temporary. It is a moment in cosmic history, just as spring is a moment in the cycle of seasons. To know this is not to despair, but to appreciate more deeply the brilliance we see now. To look at the Milky Way and know that it too is a passing phase is to feel gratitude for the chance to witness it. Perhaps this resonates with your own experience. Think of a candle near its end, burning low, its flame small but steady. It is quieter than it was at first, but there is intimacy in its glow, a closeness in its fading light. Or think of sitting with someone you love in their later years. The conversations may be slower, the laughter gentler, but the presence itself is precious. Galaxies in their quiet phase carry that same dignity. Their light is not loud, but it is enduring, and in its endurance lies meaning. The Milky Way's future may be quiet, but its story will not end. Even as its star formation ceases, its stars will continue to shine for billions of years. Their light will still travel, still cross the vast distances of space, still reach worlds that may not yet exist. In that sense, the fate of starlight is not only about fading, but about legacy. Each photon is a messenger, carrying with it the memory of a star, a fragment of a galaxy's song, travelling onward even after the source is gone. So as you listen tonight, let yourself imagine the future sky. The Milky Way has grown softer, its spirals dim. New stars no longer flare, but the older ones remain, glowing faintly against the dark. The universe is quieter, slower, more reflective. And yet, light still lingers, carrying with it stories of the past, travelling endlessly into the future. There is a melancholy in this vision, yes, but also a profound calm. For in the fading of starlight, as in the fading of day, there is an invitation, not to mourn but to rest, to reflect, to find beauty in the quiet glow that remains. And so, we have reached the end of tonight's exploration. Together we have drifted past the loud wonders of the cosmos, the black holes that so often capture our attention, and wandered instead into the quieter marvels. We have stepped into the invisible houses of dark matter halos, followed the eerie rhythms of pulsars, listened for the rare outbursts of magnetars, and lingered with the fading embers of white dwarfs. We have imagined lonely planets travelling without suns, oceans hidden beneath frozen shells, and the whispers of the universe's oldest light. We have walked through vast empty rooms called voids, traced the threads and gaps of the cosmic web, and paused in the company of galaxies that have stopped singing, their starlight mellow but enduring. The story of the universe is not only one of violence or collapse, but also one of silence, stillness, and patient transformation. It is a reminder that beauty exists not just in the fireworks, but also in the embers, not only in the crescendo, but also in the pause. The cosmos is built as much from its quiet as from its brilliance. Wherever you are listening from tonight, whether beneath city lights or a country sky, whether it is evening, midnight, or the early hours of dawn, you are part of this story too. You are made of the same atoms forged in stars, carried across time, shaped by the same ripples that seeded galaxies. You're a thread in the same tapestry, woven gently into the universe's design. So, if your eyes are growing heavy now, let them close. Let the quiet lessons of the cosmos settle softly in your thoughts. You do not need to hold on to all the details. The universe will keep them safe, humming patiently as it always has. All you need to do is rest. Thank you for being here tonight, for sharing this gentle journey. If you would like to join me again for more slow wanderings through science and wonder, you're always welcome to subscribe or to share this with someone who could use a peaceful pause. For now, may you drift into sleep easily, carried on the quiet rhythms of stars and silence. The galaxies will keep watch, the universe will continue its patient unfolding, and here, in this small moment, there is only rest. Good night, and sleep peacefully, wherever and whenever you are.